Hi, let's do this GFG question. Rearrange an array with big O1 extra space. Given an array ARR of size n where every element is in the range from 0 to n minus 1, rearrange the given array so that the transformed array becomes ARR of I. Note that ARR and transformed array are both same variables representing the array before and after transformation respectively. So it's clearly mentioned that we don't need any another array and we won't be requiring it. We need to change the same array. It's clearly mentioned because it is not recommended to do something with the original uh, input given, but here it is mentioned, so we can do. Now okay, let's see this bigger example to understand it clearly. We have given this n, which is 5. So this array is given with 5 elements. Now what we need to do, we need to travel the array one by one, and like for the first element, if you see here, it's 4. And so what we need to do, go to the fourth index, which is 0 1 2 3 4 3, where 3 is written here. Go to the fourth index and just swap it, so we will just simply swap it, and that's how we will get 3 here, and 4 should be here, like, but in the process it will also get swapped again. Okay, let's see, like for the first time we are thinking simply swapping it, so let's try this. I'm taking a iterator variable here. Let's run this loop up to n, and of course, okay, n is given already. So we are thinking, why don't we swap it simply? Okay, array of ARR of I, and let's just run it up to n minus 2, because of course it will then get swapped again. So okay, let's see. Okay, let's submit. Yeah, it's showing wrong answer. So what's wrong with our approach? Let's see. What we are doing here, we are just simply swapping, right? So we shouldn't do that. That's clearly we can see, because our answer was wrong. Why was it wrong? Let's take the same array, right? Let's travel one by one. I equals to 0, and we will just swap simply this 4 and then this 3. Next 1. When index is 1, we will swap this 0 with 3. Now the array becomes this. Let's go to second index. We will see that 2 is already here. We won't swap it. Now let's go to third index, and we'll see that 1 is there, so we will just replace 1 with 3. And at the fourth index, we will see that this array turned out to be like this: 0 1 2 3 4, which is not at all required. This was not the output. It was clearly 34201. So what's going on here? We are simply swapping it one by one and swapping it again. Okay, I also took up to n minus 2, right? So let's just remove this guy. Okay, let me remove this guy simply. Yeah, okay, let's remove this guy. But up to here also we can see clearly 0 3 2 1 4. This was our answer, 34201, which is nowhere nearer to that. So we need to apply different approach. Let's remove this. What we will do, we will run the loop, right? But we will use some trick here, and the trick is we will add and then multiply and divide. We will work something like this. Take the current element, add it to the element which is ARR of I, and then just simply mod it so that it should remain inside, and take it and multiply it with n. To get the correct output, we need another loop to simply remove this multiplication we did already. Let's take again this array, and simply we don't need to do anything, just divide it with n. So firstly we are taking the current element, and then we are adding the ARR of I, and we are taking modulus of that and multiplying by n. Next we are just removing that multiplication. So that's we are doing modulus so that it will remain inside our boundation. It will not go further to that, because multiplication can lead to bigger values, right? Okay, let's just compile it now. It's working. Submit it. Okay, it's working. Let's visualize this. So I've taken this pythontutor.com. Let's now visualize it. It's very easy. Next. So firstly we are taking this array, right? N is there. I'm printing here the original array. So original array will get printed. You will see here it's the original array, right? It's the same array. Let's go to the real loops. Okay, now we are going to the first loop, right? Yes. Current element is 4. If you can see, first element is 4, right? Then yeah, it becomes 19. How? Because we are taking modulus, like right, 4 is there, right? Now we are going to ARR of I, which is 3, and then we are doing modulus with n, which is 5. So 3 modulus 5 will be 3 itself, and then multiply it with 5, which is 15. So 15 plus 4 will give us 19. Simple. In next, yeah, in next iteration we will get 20, same as 12, and it will go on up to the very end. We will get 8 in the end. Again, now I'm just for showing it, I'm printing the same array. Okay. Yeah, it's printed, right? Let's check now. Now it's 3. Why? Because we simply divided it with n. N was 5, and if we divide 19 by 5, then it will give us 3. It will remove that point by itself. 20 by 5, so it will give us 4. Yes, 12 by 5, it will give us of course 2, because 5 2s are 10. 1 by 5, of course 0, and yeah, 5 ones are 5, so we will get this 34201 is our answer. So I've also printed this answer to show you that this is the answer. So this is how we are visualizing it. It's a very good platform. You can check it out as well, and thank you.